Hello guys, this is going to take us through one of the questions on your worksheet. So let's get started. Below here, I've just added a slide. I think it's slide 11 from our slide deck. It's just basic Coulomb's law stuff. In particular, what's important here is your prefixes. So keep a look at that. And then here we have K constant. There's some other good stuff in here, but I'm not going to go over that. You guys can look at that as you're going through your work. So starting off here, it says we have two charges, Q1 and Q2 are separated by a distance of 0.5 meters. That's really important. Q1 has a charge of plus 20 coulombs. Oh, it's microcoulombs. This is a good point to stop for a second. We only do calculations in coulombs. So we're going to have to figure out what 20 and times 10 to the negative 6th is. I know that's pretty easy here. So we're just going to say, okay, well, there's 20 with the decimal point. And we're going to move that back 6 places. So 1, 2, 3, 4, 5, 6. All right. And then we'll get 0.1, 2, 3, 4, 5, 6. All right. So there is our 20 microcoulombs now in coulombs. And so we're just looking at a 2 with 4 zeros in front of it. All right. So there we go. So let's go back to our word problem here. And Q2 is experiencing a force of 30 newtons. So we have the force. And this force is 30 newtons to the left. What force is Q1 experiencing? Well, that answer is N3L, right? So it's also experiencing 30 newtons. It's just experiencing those 30 newtons to the right. So obviously in what direction? Now, let's get to the fun part. Calculate the charge of Q1. In order to do that, I'm just going to real quick go through the guess method. All right, so what are we given? Well, we're given that Q1 is 0.12342 coulombs. We have a distance. We've been using R, but I'm just going to put a D here just because it's easier, of 0.5 meters. We have a K value of 9 times 10 to the 9th, and that is in Newton meters squared per coulombs squared. And we have a force of 30 newtons. All right. So let's go from here. Next part is our equation. Oh, unknowns. Our unknown is Q2. That's it. Equations is just our Coulomb's law equation. K times Q1 times Q2 over R squared. And then we'll substitute and solve down here. All right. So we'll start off with 9 times 10 to the 9th, right? So that's engineered exponent. On my calculator, that is second apostrophe. Will get us that multiplied by Q1, which we'll just go with 20 E negative 6 times Q2 over 0.5 meters. We have to square that whole thing here, equals 30 newtons. All right. Now let's see here. 9 times 10 to the 9th times 20 to the negative 6th is going to give us 180,000 Newton meters squared per Coulomb times Q2 over 0.25 meters squared. So we distributed that squared not only to the value, but also to the units. And that's all equals still to 30 newtons. So I guess the next thing we're going to do is multiply out that 0.25. All right. And then we have 30 times a quarter is going to give us 180,000 Newton meters squared per Coulomb times Q2 is equal to 7.5 Newton meters squared. I'm liking where this is going because I can see that we have Newton meters squared here on the right side of our equation and Newton meters squared here on the left side of our equation. So that's good. I'm liking that. So let's divide out the 180,000 Newton meters squared per Coulomb. And then add that as a fraction. And we're going to multiply by the reciprocal of that. Since we're dividing a fraction by a fraction, I just made that a fraction. On the right side, we'll just multiply by the reciprocal. So we'll go coulombs over 180,000 Newton meters squared. Now I did that because I wanted to show that we have Newton meters squared in the denominator, Newton meters squared in the numerator, and we are going to be left in coulombs here. So Q2 is equal to, so we have our answer divided by 180,000, and we get 4.167 EE negative 5 coulombs. And coulombs is what we have left. So there's our charge. All right. I hope you guys found this very interesting. Oh my gosh, this is awesome. No, but I hope you found this very informative, especially here utilizing your prefixes. You're going to see a lot of those during your work today. All right. Well, hope all went well. And if you have any questions, reach out to me on Remind. Have a great day. Bye.